This is Sharika, UR1 for CS122. This is experiment 5 in compiler, simulation of deterministic finite automata. So first here we initialize a two-dimensional array for the state transition table, and then here we get the alphabet as character and stored in array list, and then the final state as integer. Buffer reader reads from the buffer, and then here we get the number of alphabets in the alphabet set of the DFA. So that is an integer value, so we do some conversion using parseInt and we read it, and then we enter the number of states in the DFA. That also should be an integer, so in order to make sure that's an integer, we use parseInt and then we read it, and then we enter all the then we ask for all the alphabets that are needed in the DFA, and that is stored in string alphabets, and then it is stored in an array list. So we use a for loop, and then each alphabet, when we give A, B, each time it gets added, it gets appended and stored. It stores in a variable alphabet, and then this is to enter the row entries in the transition table. So now we are getting the rows in the transition table, so hence we use a for loop, and then in int1, we are converting it into integer using parseInt, and we are storing the as rows and columns inside the transition table. All the entries that we get is stored in the transition table, and then now we get the final state, and once the user is done entering, he gives -2 to stop feeding. So when he enters -2, everything, no feed, you cannot get any more feeds. So then after that, if int is not equal to -2, so if the feeding is not yet over, then the final state, we get the final state, and then that again we use parseInt for implicit conversion, and then here inside this we get now we get the starting state, and then we store it in state, and then the input is given, and then after the input string it should end with character symbol hash, so that we know that our input is over. And then so after this, if it is not equal to hash, that if the input string is not reached the end, then we store it in alphabet, and then in the transition to move on to the next state, we use state -1, and then in the index 2 we increment the index 2. Then it checks if the input has reached the final state. If it has reached the final state that we've mentioned, then it means the string has accepted. Else it says the string has been rejected. So let's see the output. So here first we give the number of alphabets, and then the number of states, and then enter all the alphabets. So let it be A, B, and then the row entries in the transitions table. So 2, 1, then 2, 3, then 2, 4, then 2, 1. Now we give the final state, and then now I give the final state, and my feed is over, so I give -2, and now I give the starting state, and now let me enter my string AABB, and then after I give the input, it should end with hash. So yeah, hence this particular string has been accepted by my DFA, and my string has been accepted.